Okay, so we're still in 3.2 again. And we're still going to look at intercepts. Okay, so we're still going to look at intercepts here. And so we're going to find the intercepts and graph. Now this one is a little bit different because we've talked about these before, and we're going to look at this one again. So let's say I give you x equals a -2. Now what's different about this one versus a lot of the others? Well, all the others, or most of the others, have had what? The x variable and the y variable. What does this one have? Okay. This one only has the x variable. And what kind of line would this be? Well, here's how we determine it. We only have an x variable, and then x is -2. So let's find the -2 on the x-axis. -2 is right here. And that's going to be your x-intercept. And we always write our x-intercept as an ordered pair. So my x-intercept right here is going to be at -2, 0. Now, if we only have the x variable, what kind of line do you think this is going to be? X can't change. So we can't go left or right any. The only thing that we can do is we can go up or down. So when we have x equals -2, an x line is going to be a vertical line. So this would look like this as a vertical line. Okay, it's a vertical line because it only has the x value. So when you only have x, it's a vertical line. So when you only have the x value, it is a vertical line. And that's x equals, in this case, -2, because we find our x value. Now, this one has an x-intercept, but what about the y-intercept? Do we have a y-intercept? No. Why do we not have a y-intercept? Well, for it to have a y-intercept, what does it have to do? It has to cross the y-axis. And this line is vertical, and it never crosses the y-axis, does it? So all it has is an x-intercept, and it has no y-intercept. So x lines, when you only have an x, it's a vertical line. All right, so what do you think about a y line? If x is vertical, then when you only have a y line, what do you think it's going to be? Horizontal. And we're building up to learning how to graph these equations without having to plot a bunch of points. So here's another one. So we're going to find the intercepts and graph, and let's say y equals 4. Okay, now, what do we have? We only have the y part. And it is a, in this case, not vertical. When you only have a y, it is a horizontal line. So it's going to be a horizontal line. Now, how do we go about graphing it? Remember, this is y, and this is -y. So where's our value at? 4 on the y-axis. So this is going to be up 4 units. Right here, and that's where it's going to cross the y-axis. Okay, and what would that be as an ordered pair? As an ordered pair, the x component is 0, the y component is what? 4, and that is your y-intercept. It is a horizontal line, so when I go to connect it, I'm just going to draw a horizontal line here. Okay, and there's my graph. Looks just like that. do we have an x-intercept? No. Why do we have no x-intercept? Never crosses the x-axis. So the x-intercept would again be none. So no x-intercept. Are we kind of seeing how to look at these in terms of the intercepts? Now we're going to move on, and we're going to start talking about the slope. So now we're going to move on to 3.3. And we're going to talk about the slope and what it is. The slope, also called m, so lowercase m, that is rise over run. And so when we talk about the rise, that's the y part. Bless you. The run is going to be the x part. So slope is also known as m, and that's rise over the run. And it's a ratio. It's a fraction. It can also be called the pitch or the grade. So if you're building a house and they talk about the pitch of the roof, that's the same as the slope. It's the rise over the run. It's a ratio. If you're working on a road crew, they talk about building a road. A road has a grade. Okay, how steep it is, the grade of the road. That's the same as the slope. So depending upon what area you're talking about, it might be the pitch, it might be the slope, or it might be called the grade if it's a road crew. But whatever it is, it's always the same, and it's a ratio of the rise over the run. And the little m, that is slope. Capital M is the midpoint. Little m is the slope. You'll talk about the midpoint in intermediate algebra. Now, let's look at 4 pictures, and we're going to talk about the slopes from an abstract standpoint. So I'm going to give you 4 different pictures. We're going to talk about these in terms of the slope. So let me draw them up here, and we'll talk about these as a whole. Okay, so we'll do one going down. One going up. And we'll do a horizontal and a vertical as well. We're going to talk about these 4 graphs together. We're not going to actually find the value. We're going to talk about whether they are positive, negative, or whether they are undefined. So let's look at this one. Now, the way I think about it is I like to think about these as a roller coaster. So I'm on this roller coaster, and I'm going to follow the graph. Now, we read from left to right, and what's happening as I follow this graph from left to right on this one? What is this doing? This is going what? Down. So that means my slope is negative. If it goes down from left to right, it's decreasing. So it has a negative slope. Now, what about the other one? I'm on the roller coaster. I'm going back up to the station, so I'm going up from left to right. So that means this is going to be what? Positive. Now, what about the next 2? Here's what I like to think about them. This is why I like to use a roller coaster as a good analogy. I'm on this roller coaster. Am I going up or down any? No, I'm just going straight across. So I'm not climbing or going down. So my slope would be 0. Okay, I'm not going up or down. This is also called a constant function. I'm just going straight across. In intermediate, you'll learn about increasing, decreasing, constant functions. This is a constant function. You're going straight across. Now, if I'm looking at a roller coaster, can I have a straight drop like this? Just straight down. No, right? Because the roller coaster wouldn't be able to stay on the track. If you try to do a straight down, the roller coaster would fall off, right? And it's unsafe. So this one is undefined. You can't do that. And that's kind of why I like to use the analogy of a roller coaster. You can't do this. You can't do a straight drop, right? It's always got to be at least a little bit of a curve, because if you don't, what happens? The roller coaster falls off, right? It can't stay on the track. You can't have just a vertical descent just like that. So that's why this one is undefined. So when we look at the diagonal lines, if it's going down, it has a negative slope. Think about a stock market. If the stock market has a graph like this, what's happening to the money? Down, going less. If it's going up, positive, you made money, right? This means you break even. This is a constant function. Same thing with the roller coaster. You're at the station. You're just going left and right. And this one can't happen. Right? You can't have a straight drop like that. So this one is undefined. You can't do that. So those are the 4 different types of slopes. Now what we're going to do is we're going to talk about how to graph a line when you're given a point and a slope. So there are 3 ways to graph a line. We can graph a line with 2 points. That's what we did in 3-1 and 3-2. We just plotted 2 points and we connected them together. You can graph a line from just an equation, or you can graph a line when you have a point and a slope. Now, what we do is we need to basically make 2 points. We've got the first point already, so we plot our first point. So our first point is 5, 2. So that's over 5, and that's up 2. So there it is at 5, 2. Now, we need another point. What is my slope? Slope is defined to be rise over run. So my m is -2. We're going to write that as a -2 over 1. Now, when we talk about rise over run, the rise is the y part. The run is the x part. So when I look at this, the top part is negative. So we're going to have to go down 2 units, and then we're going to go over 1. It's always rise, so the up and down component, over the run, the left and right part. We make it over 1. So here we are. Now, how do I get another point? What do I need to do? I need to go down 2 units. So I'm going to go down 2. And then I'm going to go over 1. And just so we can see what's happening, let's label my new point. What would this new point be? 1 unit over. So my new point is going to be at 6, 0. Now, do we have 2 points? Yes. We can now connect them together. And there's our line. Now, it makes sense because what's the slope of the line? Negative. Is this line have a negative slope? Yes. -2, so it is going down, isn't it? Let's do another one. And then we'll look at a 0 or an undefined slope. So let's do one more that has a value. And again, we're going to graph the line. And you're going to be given a point and a slope. So how about I give you the point -1, +2, and we're going to have a slope of -3/4. So this one's going to be a fraction. How do we approach this? Well, the first thing we do always is going to be you find your point. Find your starting point. A lot of times students get this mixed up. Remember, x goes first. That's the left and the right. Y is the up and down. So if I wanted to plot -1, +2, it's not going to be here, right? It's going to be -1 back here, up 2. So -1, +2. But a lot of times I've seen students mix them up. The x is the left and the right, so you always do the x and the left and the right first, then the up and down. So that's going to be -1, 2. Now, what is my slope going to be? My slope, m, is a -3/4. So it is negative, isn't it? So what does that tell me? It's negative, so it goes what? Down, and then it goes what? Over. So from this point right here, we're going to have to go down 3 units. So 1, here, we're at right here at 2. So we're going to go down 1, 2, 3, 4 units. So we're going to have to go down 4. Sorry, down 3, my mistake. Not 4, down 3. What am I thinking? Because down 3, right? So we're going to go down 3. And then what do we do from there? Over what? 4. So 1, 2, 3. Well, let me count them right here. Okay, so we're right here. So we're going to have to go down over 1, 2, 3, 4 units. So it's going to be right over here. And so down 3 over 4. What would my new ordered pair look like? Let's try to make sure we get it correct here. Okay, so we're at -1, +2, which is here. Now, what did we do? We went how many units down? 3. So that means this is down here at what? Yep, a -1, isn't it? Yep, if I count correctly, my graph's off a bit. But here's -1, and then we went what? Over 4. So this point would be right about here, and I know my graph is off a bit, but that's going to be at about, okay, -1 on the y, and over how many units? 1, 2, 3, 4 units. So that's going to be at 3, what? -1. Now we can connect them together, and we have our picture. Now you don't have to necessarily label the ordered pairs, both of them. I do, because I think it makes it a little bit easier to understand what we're doing. But if you can just go down 3 over 4, you don't have to necessarily label the point. I do, but you don't have to. Now let's go back and look at our pictures real quick. So if my slope is 0, what's it going to be? Horizontal line, right? If my slope is undefined, what is it? Vertical. Okay? If it's a different number, it's a diagonal. So either positive, it's going to go up, negative is going to go down. So this one was a number, not 0. It was negative, so it went down from left to right. Now let's look at something where I give you an undefined slope. So I'm going to give you a point, and you're going to graph a line when you give them the point and a slope. So let's say we've got 3, 5, and let me give you an undefined slope. Okay, so what would this look like? Well, the first thing we do, no matter what, is we plot our points. So we're at 3, 5. So that is over 3 and up 5. 3, 4, 5. Now, we don't have to do another point. Why not? Okay, what do we know about an undefined slope? Let's go back and look. Undefined slope, what is that? Vertical line, just like this. So my slope is undefined. So that means it is a vertical line. And it's going to go through that point, 3, 5. We can also get the equation, which we're going to be doing a lot more of in the next section when we get our equations. But what axis is this crossing? This is going to be crossing the x-axis, right? And this would have the equation x equals 3 because it crosses the x-axis here. This is our x-intercept, and it's just a vertical line. Remember, x lines are vertical lines, y lines are horizontal. So your slope is undefined. It made it a vertical line, and this is your x-axis here, so it would have the equation x equals 3. Is everyone okay with that so far? Now, we can also find the slope when you're given 2 points. So that's what we're going to be doing next. We're going to be finding the slope when you're given 2 different points. We have a formula for that. And your slope formula is m equals y1 minus y2 over x1 minus x2. So we're going to be using this formula now to find the slope. So all we have to do is calculate. So we're going to be calculating this slope. So I'm going to give you a slope. I'm going to give you 2 points. You're going to find the slope. So let's say I give you 2 points. Let's say I give you 5, negative 2, and 4, 3. Now, what we have to be careful of is we have to be careful of the double negatives if we have them. And sometimes we do have them. Now, what we do is we label our ordered pairs so that they can go into our formula. And we label them with x and y. And our first one is going to be x1. So this one's going to be x1, y1. And this one's going to be x2, y2. All right? And now we just fill in our slope formula. So we've got our formula. Now we just take a moment to plug the values in. Now watch out for double negatives. This is where students make a mistake, is if we have double negatives. This one doesn't, but many times they do. So when we plug in our values, what goes on the top? Y. So sometimes students make a mistake and put the 5 on the top. Does 5 go on the top? No, because this is what? X. This one's Y. So our formula says the Y goes on the top because that's your rise. So it's going to be minus 2. Right? That's your Y1 minus, what's my Y2? 3 divided by or over. Now I use my x's. And that's going to be 5 minus 4. And now we can simply break this down. So minus 2 minus 3, that makes it a minus 5. And 5 minus 4, well, 5 minus 4 is a 1. And what about minus 5 over 1? That is simply what? Minus 5. So what is our slope here? Our slope is negative 5. Do we see how we did work that out? Let's do another one. Pretty simple on these. We're going to find the slope again. Now this one is probably going to give us double negatives. I'm going to create one that gives us a lot of negatives. So I'm going to give you 2 ordered pairs again. How about we have 5 comma negative 2? How about we have negative 8 comma negative 12? All right, and I want you to find the slope. And I picked this one on purpose and made this one up. This one's going to have a lot of negatives, double negatives. We have to be very, very careful with the double negatives. Whenever I need a formula, I always like to write it up. The more times you write up a formula, the easier it becomes to work through. So m is y1 minus y2 over x1 minus x2. And then I label x1, y1, and x2, y2. Now we simply plug our values in. Watch out for double negatives. We may have them. In this case, we will. So we have a y1, which is a minus 2. Now we have a minus right from here. And the 12 is minus, a negative. So put a parentheses around it. That way you can see that you've got a double negative there. So we have to be very, very careful with the double negatives. What about the denominator? What do we have down below? Well, down below we've got 5 minus a minus 8. So again, be very, very careful with the double negatives. The double negative here is going to make this now what? Positive. And the double negative here is also going to make this positive. Now we have minus 2 plus 12, right? That's a 12 there. Minus 2 plus 12, that makes it a 10. And 5 plus 8, okay, both are positive, 5 plus 8, that makes it a 13. Can we reduce this down any? Nope. So what is our slope? 10 over 13. Let's do another one. So we're going to do another one here. What about undefined? Let's talk about what makes something undefined. Just so we remember. This is going to be 0. These are all 0. 0 over 12 is 0. 0 over 14, that's 0. 0 over any number. It could be a negative 5. That's still what? 0. So if the 0 is on the top and it's divided by a number, what's it come out to be every time? 0. Now, what if the 0 is in the denominator? What if I would have given you minus 5 over 0? Well, that's not 0. We can't do that. That is undefined. Another example, how about 8? 8 over 0 is what? Again, undefined. We cannot do that. You cannot take a number and divide it by 0. It cannot happen. You can't take 8 pieces of pizza and split them up 0 ways. It doesn't work. It has to be 0 on the top, number on the bottom to make it 0. If it's 0 in that denominator on the bottom half, then it is not 0, it is undefined. So we're going to work out one of these, and we're going to see what happens. So again, we're going to find the slope. Minus 5, positive 4. Minus 5, 3. I want you to find the slope here. So we've got these 2 points. We're going to find the slope. Now, what's our formula? I always like to write it up. M equals y1 minus y2 over x1 minus x2. Go back, label those ordered pairs. And we're going to label this as x1, y1, x2, y2. So we're going to plug our values in, and we're going to see what we get. So let's plug our values in. So we've got 4 minus 3 over minus 5 minus a minus 5. Be very, very careful with the double negatives, because what do we know about the double negatives here? All right, double negatives are going to make this then what? Double negatives are going to make this now positive. So the double negative here is going to make this a positive. And we've got 4 minus 3. Well, 4 minus 3, that's a 1. Minus 5 plus 5, that makes it a 0. And what about 1 divided by 0? Is that 0? No, that is what? Undefined. And by the way, that would have a vertical line for its graph. So let's now learn a little bit about. Well, I think that actually finishes up this section. Yes, it does, because that's all that there. Well, one more part in this section. We need to talk about line equations and how we can get the slope from a line equation. Okay, so one more part for this equation. It won't, or this section. It won't take long to go through. I couldn't remember if it was in this section or the next one. But we're going to talk about the slope-intercept form of a line. So we're going to talk about the slope-intercept form of a line. And the slope-intercept form is y equals mx plus b. And this m, well, that m, whatever number's in front of your x, is the slope. And the b, well, that is your y-intercept. And that would be 0, comma b. So that is what's called your slope-intercept form. So we're going to be now talking about the slope-intercept form. And I'm going to have you find the slope of a line. So this is a slope-intercept form. I'm going to have you find the slope of the line. In the next section, 3-4, we're going to be learning how to graph this line. So in the next section, after our break, we're going to be learning how to find that y-intercept and also graph this line. So right now, we're just going to find the slope. And we're going to start off with a very easy one. Now, I want to find the slope. Okay, for us to find the slope, it needs to look like this. It has to have the y by itself on the left-hand side. Once we have done that, the slope is going to be the number in front of the x. So we can go ahead and find the slope now. How would we do that? We can find the slope by doing what? By solving it for y. This is a literal equation, and we did some of these way back in Chapter 2, the first part of Chapter 2. I can solve that for y by simply moving that 4x over. So move that 4x over, and now what do we get? We get y equals a minus 4x plus 9. In the next section, we're going to be talking more about the y-intercept. But this one, we're going to be focusing only on the slope. Now, does it look like this? Yes. Has it been solved for y? Yes. So, what is the number that is in front of the x there? Negative 4. So what would your slope be? Your slope would be a negative 4. Is everyone okay with that? What did we have to do, though? We had to solve that equation for what variable? Y. So y had to be by itself on the left. Let's do another one. All right, we're going to be finding the slope. This one's going to require a little bit more algebra here. So I want to find the slope. So if I want to find the slope, I need to get the y by itself. So that's what I want. So y needs to be by itself. So what do I need to do? I need to move that 4x over. I'll use a different colored pen so we can see the difference here, hopefully. So I'm going to move that 4x over. Once I move that 4x over, now I've got minus 8y equals a minus 4x plus 7. And I need to solve this for y because I want y by itself. So what do I now need to do? Can someone tell me what I would do next? Okay, divide everything by what? Negative 8. So divide everything by a negative 8. And then you'll reduce it down. So those can cancel, and that leaves you with a y equals. And what about minus 4 over minus 8? Negative and negative makes it a positive, and 4 over 8, well, that reduces down to a what? 1/2. What about a positive over negative? Well, it leaves it as a negative, so that's going to be minus 7/8. What are we looking for here? We are looking for the number that is in front of the variable x. And what number is here? 1/2. So what is my slope? 1/2. Let's do one more. And again, we're going to try to find the slope. Okay, how about y minus x equals 5? And I made this one up on purpose. Well, we may do two of them. We'll do this one and another one. I'm trying to pick out two different scenarios to make sure we understand what's going to happen on this one. Now, I made up this one because if there is no number in front of the x, we're going to use a 1. So when I solve this for y, I'm going to have to add the x over. Now, when I add that x over, okay, that gives you y equals x plus 5, right? There is no number in front of the x. If there's no number in front of the x, we assume it to be what? 1. And I just picked this so we'd make sure we understand that if there's no number in front of that x, then we put a 1 there. So what would my slope be? 1. That's it. Okay. Now, what happens if there's no number on the end? What happens if it's a 0? What happens if it equals 0? It's still going to have a slope. Okay. So how about y? Well, let's do, we'll put a number in front too. How about 3y minus 8x equals 0? And again, we're going to find the slope. That's what we're doing here. So I'm going to solve this. I'm going to add the 8x over. And that gives you 3y equals now 8x. Okay. And what do we now need to do? Yep, divide by our 3. And there's no number on the end, but that doesn't matter because that just means your y-intercept is 0, which we'll discuss that more in the next section. But that gives you y equals now 8/3 x. So what would my m be? Yep, your m is the number in front. And my m is now going to be 8/3. We've got a little bit of time left before we take a break. Come back and talk about parallel and perpendicular lines. We're going to look at a little bit more, one more of these. We're going to look at an x line. So we're going to find the slope here. So let's say I give you this. Now what do you notice about this one? Do we have two variables? No. We only have what? One variable. Okay? I can graph this so you can visually see what the slope is. If it's x equals -7, well, what is that going to look like? It's an x line, right? And so what are we going to do? We're going to go back 7 units. 6, 7. So there's my -7. And we know it can only go what? It's on the x-axis. It can't go left and right, because that wouldn't make sense, would it? What does it have to do? Up and down. So that's going to make it a vertical line. Like this. Now, once you've got the picture, you can see the slope. If we have a vertical line like this, is my slope 0 or is my slope undefined? Which one? It's a vertical line. Right, so it's a vertical line. So my m would be undefined. Okay? If it was a y line, it would be a horizontal line, and it would have a slope of what? 0. So if you only have one of the variables, you can either remember that an x line is undefined, or you can draw the picture and visually see that it has an undefined slope. Let's go ahead and take a short break. We'll come back, and then we'll talk about parallel and perpendicular lines. And then we'll try to get through 3, 4 as well. These sections are very, very short until